All right, guys, so what we're doing today is going over more solving logarithmics and exponentials. And we'll do a few of these here. We'll do 2 of the exponentials and 2 of the logarithmics, because most of what we're doing here is not anything new. It's just re-going over the stuff that we did 2 days ago. But we're kind of looking at it more in depth and at a little bit higher degree. The process isn't going to change. What we're doing isn't going to change, but the numbers are a little bit different. Now, there is a number that you need to change on the note sheets because it's not 13. We need it to be 303. Because when I was working these this morning, making sure everything looked right, well, turns out 13 is not a solution for this here. It wouldn't work. It'd give us no solution. So we're going to work with this one instead, with 303. Now, whenever we're solving these here, especially with exponentials, we want to get x by itself. So what can we do first? We can subtract 3 from both sides. So it's that 5e to the x squared plus 4 is less than 300. Then what can we do next? I wouldn't do natural logs yet. We're going to do them. I would divide by 5 first, because we want to get the e by itself. And ln of 5e would work, but we'd have to split that up into addition to be able to get the 5 away from it. So it's a little bit easier to go on and divide both sides by 5 first, because these here would cancel, giving us e to the x squared plus 4 is less than 60. And then we would use ln. Now we would use it, because we want to wait until e is completely by itself. We don't have anything being multiplied or added to it before we apply it to both sides. Any questions or other questions so far? Now we need to solve for the value of x. So what can we do next? We can subtract the 4 from both sides, which will tell us that x squared is less than the natural log of 60 minus 4. What do we need to do next? We would square root both sides, because the square root of x squared would become x is less than what? Square root of the natural log of 60 minus 4. But, okay, I'll give you all a second to write. So, normally when we square root both sides, what do we normally add into it? Because there's normally a symbol we write in front of the square root, plus or minus, because whenever we square root both sides, we add plus or minus. Now, because we have an inequality, the negative case, we have to change the sign. Because it's dealing along the properties, if we multiply or divide both sides by a negative, you have to flip the inequality sign. That's what it's saying here. And that's what we would have to be doing here. Now, since it's not asking us to round to 3 decimal places, we can leave it as this here. And that's how we're going to leave it. Because if I wanted to, I could find out what these numbers were by just plugging them into a calculator and seeing what the square root of the natural log of 60 minus 4 is, and what the negative natural log of 60 minus 4 is, and we would get those answers. But these here are both solutions, and they both work because it's going into the exponent. Since it's going into the exponent, both of these solutions will work for this here. Any questions on how we got to this? This here is our answer. So it's not too much more involved than what we've been doing. It just has a few more steps. All right. Let's look at the next one. 5 plus e to the negative x is greater than 14. We subtract 5 from both sides, yes. And if we subtract 5 from both sides, we get e to the negative x is greater than 9. Then we can apply the natural log to both sides. Which this here ln of e will simplify to 1, leaving us with negative x is greater than the natural log of 9. And then what? Huh? We can divide by negative 1, yes. Because we need x to be positive. Because a negative divided by a negative is a positive, and x divided by 1 is 1. Over here we're getting negative natural log of 9. And our inequality symbol would be because again, anytime we multiply or divide by a negative, we have to change the sign. We have to flip it. And that's it. That's all we have to do for this here. Any questions on any of these here so far? Okay. Let's look at our first logarithmic. The natural log of 2x minus 3 cubed is greater than 6. Now, the way that we're going to treat this, almost if we were being mathematically kind of sticklers to it, we would really need another set of parentheses around it. But we're not going to have to write that. We're going to treat it as the 3 being attached to the 2x minus 3, not the natural log cubed. Because depending on how you type this in for some calculators or some systems, it thinks we have it as this way here, that the natural log itself is being cubed. But it's not. It's just the 2x minus 3. So really what we're looking at is the natural log of 2x minus 3 cubed is greater than 6. And the reason that there's a difference between this is that if the natural log itself is being cubed, we can't use the power rule. But since we are treating it this way, we can use that power rule to move the 3 out front, which is really telling us that we have 3 natural log of 2x minus 3 is greater than 6. Because we can use that power rule. Now what can we do next? Not subtract, but since 3 and the natural log are being multiplied together, we would undo it with division. We would divide both sides by 3, which will tell me the natural log of 2x minus 3 is greater than what? 2. Now what can we do next? Put e to both sides. Because e to the ln will simplify out, leaving us with 2x minus 3 is greater than e squared. And what can we do next? Because again, we're solving for the value of x, so the first thing we can do here is add 3 to both sides, which will tell us that 2x is greater than e squared plus 3. And then we would divide by 2 to finish this up, which will tell us x is greater than e squared plus 3 divided by 2. Now this here would be the final answer because e squared plus 3 divided by 2 is going to be a positive number. And if we're saying x is greater than it, x has to be positive values, which is good because it means that whatever value of x I plug in here will not be 0. It cannot be a negative. Any questions on this here? Any questions on anything we've done so far? Okay. Let's look at one more. I'm not going to make you go through this. We're not going to go through this entire sheet. But looking at the last, what is that? 3 logarithms. Which one do we want to look at?
The very last one.
The very last one? -2, natural log of x minus 6 to the -1 is less than or equal to 6. Now again, just like with the last one, the -1 is attached to the x minus 6 because we need that to happen, because if it's not, if it's attached to the natural log, really what we're saying is that we have -2 over the natural log of x minus 6 is less than or equal to 6. This will make things a little bit different. This will make it an entirely different problem that we would have to solve. So we're not going to solve it that way. But looking at this problem here, what is the first thing we can do? I would divide by -2 on both sides. Because when we divide both sides by -2, the -2 and -2 would simplify, leaving us with the natural log of x minus 6 to the -1 is greater than or equal to -3. Since we divided by negative, we have to change the inequality sign from less than or equal to greater than or equal to. Any questions on this so far? Now, it'd be very tempting to apply e to both sides, but I want to do something a little bit different. We can move the negative out front. We can move the -1 to the front. Because our power rule states that we can move the exponents from the exponent to out in front of the logarithm, which will really tell me that I have negative ln of x minus 6 is greater than or equal to -3. Now what can we do? Yeah, let's go on and get rid of that negative. It is indeed. So now we have the natural log of x minus 6 is less than or equal to 3. Now we can put e as the base of both sides. And e and the ln would simplify, leaving us with x minus 6 is less than or equal to e to the third. So we'd add 6 to both sides, telling us that x is less than or equal to e to the third plus 6. Now, does this include negatives? is -1 less than or equal to e to the third plus 6? So e to the third is going to be a big irrational, well, it's not going to be too big, but it's going to be an irrational number because it's 2.7. Well, 2 cubes 8. 8 plus 6 is 14. It's going to be bigger than 14, but we know it's going to be a positive number. So if x is less than that, well, that includes any number less than 14. So would this include negatives? Well, I guess it would, wouldn't it? So we do have to figure out our restriction. And inside the logarithm was x minus 6. And it has to be greater than, and I believe I said or equal to 0 the other day. So let's look at this here. So how would we solve this here? Add 6 to both sides, which tells me x has to be greater than or equal to 6, yes? We have this here for our equation, -2 parentheses ln of x minus 6 to the -1 is less than or equal to 6, yes? In the calculator, we're not going to type the whole thing in. Let's type in this part. So let's see what ln of 6 minus 6 is. Let's see what the natural log of ln of 6 minus 6. Right, it is an error. Because really, and I noticed this here is supposed to be just, because when we're solving this here, we're not going to use greater than or equal to, it's just going to be greater than. And I'm going to show you here in a second why. So the actual answer for this here, and the ones where we had restrictions the other day, it should just be greater than, it can't be equal to 0. Any questions on this here? Because that's the last one we'll look at, but I want to look into this here in a little bit closely. The natural log of 0, because really 6 minus 6 is 0, equals y. Because that's what we're going to write, and I'm going to write this out. Now, if we rewrote this as an exponential, y to both sides, we're saying e to the y is equal to 0. Well, when we first talked about these exponential growth and exponential decay, we said that this here would never actually reach 0, yes? Because we talked about the overall graphs as a function that did something like this here, and it got really close to the x-axis. It got really close where y, the value of y would be 0, but it never actually crossed it. Because as we put bigger, or kind of here, for these values along the x-axis, as I put smaller and smaller values, or bigger negative numbers, even if we put e to the negative 1,000, well, this is the same as 1 over e to the 1,000. Well, that's never going to be 0 because the numerator is 1. The only way that it can be 0 is if the numerator is 0. So this function will never equal 0, so I cannot take the natural log or the logarithm of 0. It just doesn't work. Does that kind of make sense? And looking back at it, I come across that, so that is a small error that I had the other day. So we can't have it equal 0. So when we do the restrictions, we have to have it as greater than, not greater than, or equal to. Small change. But that is all we are going to do for today.